With 15 years of experience in the industry, we design and produce convectors and have perfected our products to reach the highest level of quality. This video demonstrates the issues in terms of the design, quality, installation, and operation of our vectors that we have detected and solved. Housing material. Nearly all housings of the trench heaters on the market are made of painted carbon steel. Often, they are subject to further treatment after painting. Thus, the areas of treatment remain completely uncovered. When in contact with chemically aggressive substances as concrete, the housing of the convectors often start rusting on the most prone areas, such as the edges of parts and openings. Often, such rusting can even be observed shortly after the installation. To resolve this issue, we have decided to use stainless steel so that the housing will never be subject to rusting. Therefore, we can provide a 30-year warranty for the housing parts. In addition, stainless steel is on average 45% stronger and 54% harder than carbon steel, making our appliances much more load-resistant at the time of their transportation and installation, as well as during their operation. Housing rigidity. Usually, trench heaters are mounted inside concrete. Thus, they need to resist the high pressure that results from pouring the concrete. Weak housings will deform under pressure, and later, placing the cover grills becomes impossible. Therefore, we have strengthened our housing with rigid ribs in amounts varying from 2 to 7, depending on the length of the housing. The amount of rigid ribs, together with the resistant material of the housing, ensures the stability of the shape not only during the installation, but also at the time of transportation and operation. Vertical load resistance. Trench heaters are one of the few heating appliances on which people will be standing and walking, so they must withstand a significant vertical load. In most cases, the housings are supported by 4 screws located in the corners of the housing. Sometimes, longer housings are supported with 2 additional screws in the middle of the housing. Experience has shown that this number of screws is not sufficient, and the housings become bent under the vertical load. Therefore, we support our convector housings using 6 to 20 extremely rigid 10 mm diameter steel legs. This increases the vertical load resistance of the housings to 200 kilograms per meter. Housing tightness. When pouring concrete around the convector during its installation, part of the concrete through the openings of the housing enters the inside of the housing. This compromises the visual appearance of the convector, increasing the likelihood of corrosion, and may damage the parts situated inside. Removing concrete from the convector is complicated. To prevent this, we equip our convectors with sealing elements for the inlet pipes and cables, as well as with blinds for unused openings. Therefore, no concrete can enter the convector. The sealing elements also provide additional protection for the inlet pipes and cables to prevent rubbing on the edges of the housing openings. Sound insulation. Floor-mounted convectors are usually installed directly on the flooring. Noise from the metal fastening components of the housing passes into other rooms downstairs in the premises where the convectors are installed. All fastening components in our products have noise-insulating elements. In this way, none of the metal parts of the appliance come into contact with the flooring. Therefore, the noise propagation is completely insulated. Maximum operating pressure. The maximum operating pressure for the majority of heating appliances is 10 bar. In tall buildings, heating systems are often tested after their installation at a pressure of 10 bar or more. This is the pressure limit at which the risk of an appliance failure occurs. The maximum operating pressure of our convectors is 25 bar, whereas the factory testing pressure is 30 bar, and the maximum maintained pressure is 110 bar. Devices that maintain higher pressures are resistant to hydraulic tests, even at extremely high pressures, preventing hydraulic shock, and may be used in very tall buildings. Protection of heat exchangers against rubbing. Typically, heat exchangers are attached to the appliance by placing the soft copper tubes into hard steel brackets. At the time of transportation and operation, the heat exchangers move and rub against the brackets, making holes over time and resulting in water leakages. Furthermore, heat exchangers can cause unpleasant sounds when rubbing against the brackets at the time of their operation. To solve these problems, we install special plastic pipe clamps in our convectors that protect the heat exchanger from damage and prevent sounds from occurring. In addition, such pipe clamps serve as brackets, so the heat exchangers are securely mounted in the housing. Air conveying components. The design of trench convectors with natural convection must ensure the smooth circulation of cool and heated air. Laboratory tests revealed that the cool air, as it moves under the heat exchanger, partially mixes with the heated air. In this way, part of the warm air is directed back under the heat exchanger. In other words, part of the airflow recirculates. This reduces the output of the appliance and impairs the smooth rise of warm air in an upwards direction. After this problem was noticed, we designed special air-conveying components that completely separate the flow of cool and warm air and increase the heat output of the appliance. In addition, the air-conveying components serve as an additional support for the decorative grid. Fans. The fan is one of the most important components of a convector with a forced convection. The type and quality of the fan determines the service life, output, and noise level of the appliance. Some convectors are still equipped with fans that have outdated technology AC-type motors. All fans in the Konveka convectors are exclusively equipped with EC motors featuring the latest technology. Modern EC technology motors are currently the most efficient and effective motors. Their energy consumption is 84% less when compared to AC-type motors. For an average administrative building, approximately 4.7 kilowatts of power consumption will be sufficient in the case of an EC motor, whereas fans with AC-type motors will require 30 kilowatts of power. EC motors start at 10% of their maximum rotation speed, while the speed is controlled smoothly without jumps. As a result, their operation is almost imperceptible. AC motors cannot rotate slower than at 50% of their maximum rotation speed. Their speed is controlled by using a frog jumping algorithm. This reduces their service life and increases the noise level. The EC motor starting current is equal to the operating current, so its operation is smooth and overloads are prevented. The AC motor starting current is up to 6 times higher than the operating current. Such overloads reduce the service life of the fans, the control system, and the entire power installation. The EC motor is a low-noise motor with a noise level that is considerably lower. It has no brushes that require permanent replacement, resulting in low maintenance and an extended durability. Air intake filters. The quality of the air passing through the convector has a profound effect on the service life and operational quality of the appliance. When the convector is running, the fans draw in the ambient air and push it through the heat exchanger. Uncleaned air passing through the heat exchanger contaminates it with dust, animal hair, and fine debris, which rather quickly is followed by a significant reduction in the amount of air passing through the heat exchanger and, consequently, the output of the appliance. Therefore, the air passing through the appliance must first be cleaned. In most cases, the design of the convectors leaves this problem unsolved with only a protective grid installed. This is not enough to trap the dust. So we put a special mesh into our convectors to ensure an adequate quality of the incoming air. The mesh may be easily cleaned using a vacuum cleaner without removing it. Grill inserts. Very often, grill inserts are made of plastic. Experience has shown that plastic inserts exposed to heat and UV radiation will shrink over time. As the inserts shrink, the length of the entire grill decreases, so that after a while the ends of the convector become uncovered. Besides this, UV radiation produces fading in plastic inserts, so their color becomes different from the color of the grill over time. This problem was solved by using aluminum inserts instead of plastic. Aluminum inserts are heat-resistant and UV-resistant, and thus retain their dimensions and color throughout the entire service life. Reliability of the heat output data. The heat output is the key characteristic of heating appliances. At first glance, the majority of convectors look similar. However, their heat output may differ a lot, so it is crucial that the output data provided by the manufacturer is correct. Every manufacturer of heating appliances provides output data for its products in catalogs. How reliable is this data? We can trust the data only if the manufacturer has verified the output of its products in an independent, accredited laboratory and has test reports that conform to the effective standards, such as International Standard EN 16430 for heating and cooling trench heaters and EN 442 for freestanding and wall-mounted convectors. All Konveka products are tested by independent accredited laboratories and have output measurement reports that are compliant with the applicable standards, so the outputs indicated are completely reliable. Closing remarks. Thus, to improve our convectors, we started making them of stainless steel, reinforced the housing by ensuring its resistance to the pressure of concrete, increased the vertical load resistance, tightened the housing to prevent concrete from entering the appliance during its installation, provided for the insulation of sound transmitted through the housing, increased the maximum operating pressure, protected the heat exchangers against rubbing, introduced air-conveying components, employed only the most efficient EC fans, included inlet air filters in the standard set, started making grill inserts of aluminum, declare the heat and cooling output as determined exclusively by independent accredited laboratories.